second. All right. 4.4, adding and subtracting like fractions, the least common denominator and equivalent fractions, right? So definition, a least common denominator, the LC, or known as the LCD, it is the smallest possible number divisible by all the denominators in the list. It is also the least common multiple, LCM. So LCM and LCD mean the same thing. Method 1. So I'm going to show you two different methods on how to find the LCD. This first one is finding the LCD of a list of fractions using multiples of the largest number. Now we're going to write the multiples of the largest denominator starting with the number itself until a multiple common to all denominators in the list is found. The multiple found in step 1 is the LCD. Now, if you were able to follow with that method, that's great. But if not, do not worry. You will see what this method is asking us to do in the next slide. Is anyone still writing this slide before I move on? All right, let's move on. Here's example 1. Find the LCD of 3/7 and 5/14. I'm gonna go ahead and give you guys about 1 minute to set up for A, and then I'll go ahead and jump in. All right, so finding the LCD of two fractions class is essentially us finding which denominator can we find. So LCD, so we're gonna write down the two denominators, 7 and 14, and our goal is to find the ones that match. So in this method, it wants to use the largest denominator first. So a multiple of 14 is just adding 14 plus 14, which is 28. Now we get the second denominator 7 and we count by sevens until we get a matching one or common one. So 7 plus 7 is 14. Then we have 21 and then we have 28. You notice here that we have two common denominators here, the 14 and 28. Now the concept is called LCD, which is least common denominator. Which one would you say is least compared to the 14 and 28? If you said the 14, you are correct. So the LCD for this one is equal to 14. And we're done. Any questions on what we did here?
We're just doing the two bottom parts of the
Yeah,
fractions.
we're not changing the values of the fractions here. Right here, the objective of this lesson is finding the LCD. All right, B, finding the LCD of 11/12 and 7/20th. So we're gonna do 12 and 20. Let's go ahead and do 20s first. So 20, 40, 60, 80. I think that should be enough. You can even do 100. Doesn't matter how many you do, right? But remember, to learn mathematics, to do mathematics is to kind of make your life easier, not harder, okay? So now we're gonna go by 12s now, multiples of 12. 12 plus 12 is 24. 24 plus 12 is 36. 36 plus 12 is 48. Now we're gonna keep doing this until we get a common one that is the same with the 20s. 48 plus 12 is 60. And right there, we found our LCD. Does anyone understand what the process is for method 1? This is the process for method 1 here. Any questions for method 1? All right. If there are no questions, let's go ahead and check out your first practice problem. Here you go. I'm gonna go ahead and give you guys, since there's 2 of them, I'll give you 3 minutes. And then if y'all finish beforehand, just go ahead and relax, stretch yourself a little bit. All right, guys, so that was my timer. Did anyone would like to share what they got for the LCD for the first one? If you guys got 16, you're on the right track. Ah, Priscilla, you got 24. Let's check it out. 24. So we have 8 and 16, right? We want to go with multiples of each number. So 16 plus 16 is 32. So you want to add the same number that's there, Priscilla, to get the next multiple of it. So to get the next multiple of 32 is 32 plus 16, which is 48. Now that we have enough of these, we do the 8 now. 8, then 16, 24, and 32. Now notice how there's only a 24 with the 8 and not the 16. So 24 cannot be it. And notice how we have 32 and 16, but we want the lowest one, the least. So 16 is the LCD. Does that make sense, ma'am?
Yes, I wrote the fraction down as 11/6 instead of 16.
So yeah, if 11/6, the LCD for that denominator is 24. So good job on getting it right with your example. But yeah, you're good. So you're good. That's what matters. As long as you understand the process, right?
Yeah,
Good. Thank you for clarifying.
you're welcome.
All right. Anyone want to share what they got for B, guys? Go ahead and tap it into the chat. What'd y'all get for the second one? Let's see how y'all did. I see 200 and 150. There's lots of 150s. Let's see how y'all did. Move this little box. And it is 150. Now, Jacob, we got 200, right? So let's write down both of our common denominators. Now 30 is gonna be 30 plus 30 is 60. 60 plus 30 is 90. 90 plus 30 is 120. 120 plus 30 is 150. 150 plus 30 is 180. 180 plus 30 is 210. So 200 isn't even part of the multiples of 30, Jacob. You see that? So now for 25, you go ahead and do 50, 75, 100, 125, 150. And that's where we see the 150, sir. Did you see your mistake versus how we did it here?
Yes.
Okay, good, good, good. As long as you know the difference and you make that correction. Any
I had a-
questions?
I had a question, sir. So we're looking for the lowest number.
That is correct. So LCD is the least common denominator. So the lowest same number from both denominators. That is correct.
Okay, because for the first one, I had got 32.
Ah, that they are in common, but is it the lowest they have in common?
Yeah, that's where I went wrong. Thank
There
you.
you go. Yeah, yeah. And then you want to make a little note for yourself, and you know, but you can't. Note, always take the smallest one for LCD for future you. All right. Now we're gonna learn method 2, which is gonna be our standard. This is what I want the usage to be. It's gonna be a little complex what we're gonna be doing with method 2, but I encourage everyone to step on it or to like pay close attention and then see and do it from now on, finding the LCD. So I'm gonna go ahead and give you guys about 4 minutes to write this information down. There's a lot of steps, and we'll move on. All right, guys, that was the timer. So method 2, finding the LCD of a list of denominators using prime factorization. Step 1, writing the prime factorization of each denominator. That's the first thing I'm going to be teaching you first. Step 2, for each different prime factor. So a factor is a number that multiplies each other. So like 2 times 3, those are both factors. So we're gonna circle the greatest number of times that factor occurs in one factorization. And then step 3, the LCD is the product of the circled factors, okay? Now recall, a prime number only has factors of 1 and itself. Like for example, 2 is a prime because it's only 1 times 2. 3 is also a prime. All these numbers are primes because of the same fact. 3 can only have factors of 1 times 3. 5 is a prime because 1 times 5, and so on. Okay. Anyone still writing these steps down before we move to the example? All right, I'm gonna go ahead and move on. Example, finding the LCD of negative 23 over 72 and 17 over 60. Now remember, the LCD is from the denominators. Now, can we do method 1 where we write the multiples of 60 and the multiples of 72? Yes, that is correct. We can do that, but we are not going to do that. Is not going to be the case here. We're learning a new method with this example. So I'll give you a few seconds to set this up into your notebook before we jump in. Now, the first factor we're going to be breaking down is we're going to be doing 72. Now I'm going to bring back those prime numbers over here. Prime. It was 2, 3, 5, 7, 11, and 13. Now there's more prime numbers, right? That could it be, but we're going to use these for now, these first 6. So to find the prime factorization of a number, you start with the number here, and then you write two factors that multiply and give you 72. Could anyone tell me what 2 numbers can we multiply to get 72? Any 2 factors. The only thing is they have to be whole numbers. Anyone know any 2 types of numbers multiplied that give me 72?
2 times 36.
2 times 36. So I'm gonna take this one. That was the first one I heard. So it'll be 2 times 36. Now, if you ever get a factor that's one of these numbers, these prime numbers, 2, 3, 5, 7, 11, you circle that number because you cannot break it down any further. Because let me show you. Don't do these steps right now. So 2 is 1 times 2. 2 is 1 times 2. 1 times. So it's never going to stop, right? You see that? That's why we put a circle there, because we can't go any further with it. But notice how 36 wasn't on that list. So now we're going to break down 36 further. Can anyone tell me 2 factors of 36? What 2 numbers multiply give me 36?
12 times 3.
What was that? 12 times 3. So 12 times 3. That's what you said, right? Do y'all
Yes.
see any of these numbers in that prime list? Yeah, the 3. So circle the 3. Now let's look at the 12. 12 is not on there, so that means it can be broken down to other factors. Can anyone tell me any factors for 12?
6 times 2.
6 times 2. 2's on that list, so we circle the 2. Now, 6 isn't on there, so that means that can be broken down. And 6 is very simple. That's just 2 times 3. And those are all on the list. So 72 is the same thing as equal to, how many twos do you see? 2, 2, 2, that's 3 twos, so it'll be 2 times 2 times 2, and then times 3 times 3. Do y'all see that? There's 3 circle 2s and 2 3s. Now we're gonna do the factor tree for 60 now. Can anyone give me any two numbers that multiply that give me 60?
10 times 6.
10 times 6. Read my mind. Now, am I gonna circle any of these?
No.
No, that means we can break down each one. Well, we know 6 is just 2 times 3 because I did that already. So I'm gonna just do that for you. Now those are on the list. 10 is what two numbers multiplied?
5 times 2.
5 times 2, and those are both on the list here. So 60 is equal to 2 times 2 times 3 times 5. Everyone agree, or everyone see how we made the prime? Now these right here on the right side, these are called prime factorizations. That's what we just did right now. So this is step 1. This is step 1 from method 2. Any questions on step 1? All right, so now let's go back to look at step 2. Step 2 says for each different prime factor, so every different number that we have on those factors, we're gonna circle the greatest number of times they occur. So if there's the two numbers have 3s, we're gonna circle the one that has the most 3s in the one factorization. And it's gonna be for each different one. So looking for the different ones we have. So we have 2, 3s, and 5. So which one has the more 2s, the blue or the red? The 72 or the 60?
The 72.
Yeah, the 72. So we're gonna circle those 3 2s, guys. Because everyone knows why, right? Because there's more 2s there than the 60. Now, since we already circled the one that has the most 2s, can someone tell me which one has the most 3s? The 72 or the 60? We have to have a circle for each different prime factor. So we have a circle for 2s. Now we have to circle the 3s. Which one has more 3s?
72.
72. So circle those 2 3s, class. Did I circle each different prime factor now, or am I missing one still?
The 5.
The 5. And notice how there's only one that has the 5. Then we just circle that 5 by itself, the solito one, is all solo. Now that this was step 2, the circling is step 2 of the method. The circling. All right. To finish off, step 3 is the LCD. What is the LCD? Well, the LCD is pretty much all the circles we circled. We're gonna write them down here. 2 times 2 times 2 times 3 times 3 times 5. And then use your calculator to multiply all these factors. So I'm gonna get my calculator on my phone. If y'all wanna do it with me, go ahead. 2 times 2 times 2 times 3 times 3 times 5. I did it. If someone can double check my math, I got LCD is equal to 360. Did someone check for me and did I get it right? Did I multiply right?
Yeah, that's correct.
Thank you. Any questions on step 1, 2, or 3, guys? All right, if there's no questions, as you're about to try it out by yourself, here's your practice problem, guys. I'm gonna give you guys 3 minutes because there's a lot of steps here, and I'll add more time if needed, okay? Good luck. So you're doing the same thing we just did, okay? I'm actually gonna give you more than 3 minutes. I'm gonna give you 4 minutes. Now add more time if needed, okay? Good luck, everyone. All right, that was the 4-minute timer. Is anyone still working on it and would like an extra minute or two?
I would like just like 30 seconds.
30 seconds, okay? Anyone else? An extra, that sounds like a minute to me. Okay, we'll go ahead and do the 1 minute.
Okay, I'm done.
All right, let's go ahead and put in your answer in the chat, guys, to see how everyone did before I reveal. Thank you, Jacob, for your message. Anyone else? Excellent. We have a lot of similarities. Let's see how you guys did. Ready? And it is 1,080. Nice, guys. Look at you applying method two, like your college students. Very impressive, guys. Very impressive. All right, you're correct. 1,080 was the LCD. Does anyone have any comments or concerns about the method two? Because we were going to be using or utilizing method two the majority of this semester. Okay. Now, method one, it's okay to use if the numbers are simple, but if it gets complicated, method two will be our choice. Okay, guys. Any questions on the method at all?
I do have a question. Does the
What's up?
negative matter?
Ah, great question. So for the LCD, negative does not matter. But if the question said, find the LCD of these fractions, then rewrite the fractions with the new denominator. Then the negative will apply for the second question when you're rewriting the fractions with the new denominator.
Oh, okay, thank you.
No, thank you for your question. It's a great question, okay? All right. Now, helpful hint, guys. So I do want you to write this because I don't want you to make this mistake. I've seen it happen a lot. This is why I included this in my notes. If the number of factors of a prime number is equal, like there's the same number of threes on the both the numbers, and you only circle one, not both. So I'll give you about 2 minutes to set this helpful hint into your notebook, and then we'll move on unless people need more time than 2 minutes, okay? Now, don't say, okay, I already know I'm not gonna forget that, okay? Let's be honest, think about future you, okay? Yes, you right now knows, but right now, let's take care of future you, right? Remember, my notebook is meant to help you out for your next course and later on, right? All right, would anyone like more time? All right, let's move on. Ooh, now the plot thickens, class. Now we have three fractions to deal with. And if you look at B, now we have variables as our denominator, right? Whoa, I'm gonna go ahead and give you about a few seconds to set up A into your notebook. Give you 30 seconds. All right, let's take a look at A. So A, we're gonna be doing method 2, but you notice there's three fractions. So we're gonna be doing three prime factorizations, okay? So let's focus on 15 first, right? So 15, can someone give me two factors that multiply that give me 15? I think we've done this before. It was 3
3 and 5.
and 5. And are these on the prime list? Do I circle them or do I keep going?
Circle
I
them.
circle them, thank you. 'Cause I know what to do, right? But when I ask these questions, is to ask to check, do you know what we're doing? So we have 15 down. So I'm gonna do all the prime trees first, and then I'm gonna write out their factorization, okay? 18. 18 is what times what? What two factors multiply give me 18?
9 and 2.
9 and 2. Can I circle either one of these?
2.
Thank you. Now 9 can be broken down to 3 times 3, which is one of the primes, so we can circle that. So we are now done with 18. We're now gonna jump on to 54. Can someone give me two factors that multiply that give me 54?
18 and 3.
18 and 3, that's correct, and we can circle the 3. 18 is the same thing as 9 and 2. And we know 9 is 3 and 3. So now we have all of them broken down. So now we're gonna write out the prime factorization for each one. So 15 is equal to just 3 times 5. 18 is equal to, notice how I like to go from least to greatest, 2 times 3 times 3. And then 54 is 2 times 3 times 3 times 3. Now remember, our goal is to circle each prime factor, each different prime factor, whichever one comes out the most. So let's look at the smallest one first, 2. There's 1, 2 with 18, 1, 2 with 54. Question, does it matter which 2 we circle, yes or no?
No.
No, it does not. So I'm gonna go ahead and circle this one right here. I'm gonna switch up my color real quick. I'm gonna go ahead and circle this middle 2. Now we have a 2 circle. Now we gotta see which one has the most 3s. The 15, the 18, or the 54. Which one do you see? Which one has the most 3s?
54.
The 54. So circle those 3 3s. Now, am I done, or is there another factor that I'm missing?
The 5.
The 5, good catch. That is step 2. We did step 1 up here. This is step 2. Now for step 3, we're gonna go ahead and do LCD. equals, now what do we write to get the LCD class? What are we gonna write to multiply it together?
2 times 3 times 3 times 3 times 5
That's correct.
equals
I got 270, but that was mental math. Can someone come double check me, please?
That's correct.
you're correct.
Thank you. Nice. Look at you guys doing method 2. How y'all feeling about method 2? Seeing it a second time now. Do y'all feel a little better with it the more exposure you see?
Yeah.
Good, good, good. You'll definitely get that practice whenever you start working on the assignments on your own. All right, let's take a look at the second one, the one with the letters now. So find the LCD of 3/5, 2/x, and 7/x cubed. All right, guys, let's take a look at B. So if you notice, when we try to do the denominators for B, what do people notice about 5? Is 5 a prime number on its own already? Yeah, it is. It's part of that list, right? So we can, it's just 1 times 5, 1 times 5. So we could just stop there at 5. X. X is just X, 1x by itself. So technically the only factors of X is 1 and X. So X is done already too. X cubed is actually X times X squared. And we know X is prime already, and X squared is just X times X. So now we're gonna go ahead and write the prime factorization now. So we know 5 is just equal to 5. We know X is equal to X. We know X cubed is equal to X times X times X. Now, class, can y'all tell me how many different prime factors you see? And this side over here on the right side. There's a 5, that's one prime factor. What's the other prime factor you see? The X. Yeah, the X. That's it. There's only 2, 5 and X. So we're gonna circle each one that comes out the most. So we know 5 here is the only 5. Now, which X has the most X's? The X or the X cubed?
X cubed.
It's cubed. So the LCD class is gonna be 5 times X times X times X, but do we know what X times X times X is? Yeah. It's 5x cubed. And that is the LCD class for B. What questions do we have on method 2 for B? If we have any.
I have a question. So you will only ever circle the most if there's multiple, right?
That is correct, yes.
Okay, thank you.
No, thank you for your question. All right, here is your next practice problem, guys. Go ahead and give you guys about 4 minutes for these, and I'll add more if needed, okay? Good luck. All right, guys, so that was the 4-minute timer. Would anyone like more time to keep working? All right, let's go ahead and put in the chat what you got for the first one before the big review. Let's see how everyone did. Got 120, 120, 120, 120. A lot of 120s, guys. Oh, that's unfortunate news. I think I need to recheck your work. Psych. Good job, everyone. You got 120. Nice. Nice, nice, nice. All right, y'all ready for the second one? Go ahead and put in the chat what you got for the second one. So nerve-wracking, right? 11y, 11y, 11y. Guys, what about the factors of 3 and 8? Nah, I'm just kidding. Nice. 11y, guys. Good job, good job. How's everyone feel about these practice problems? I feel pretty good about your work and stuff. Do you feel comfortable? Anything that you're not comfortable with or you have questions about? Good, 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 good. Yes, I can work out one. Thank you for asking. All right, so 20, guys. Let's go ahead and break down 20 first. Can someone tell me factors of 20? Any two numbers to multiply that give us 20? Remember, it's a practice problem. So this 2 and 10. So 2 is a prime, so circle the 2. And we know 10 is just 2 times 5. So we're done with 20. Now we're going to break down 24. Can someone give me factors of 24?
Six and
6 and 4. And then factors of 6.
3 and 2.
Excellent. And then we know 4 is just what?
2 and 2.
Correct. Now we got the big one, 60. What factors give me 60? I think we did this one, right? 6 and 10, right? And then 2 and 3. And then 2 and 5. So now we write them all out. So we get 20 is equal to 2 times 2 times 5. 24 is equal to 2 times 2 times 2 times 3. And then 60 is 2 times 2 times 3 times 5. Can someone double check my prime factorization? Did I get those three? Did I write them out correctly or am I missing something? Okay. I think I'm good. Next thing I have to say is now we got to circle each prime factor, each different prime factor, whichever one comes out the most. So which 2 am I going to circle? The 2s from the 20, 24, or 60?
From the 24.
Correct. All right, so then the next prime factor after 2 is 3. There's 1 3 with 24, 1 3 with 60. Which 3 do we multiply, circle?
It doesn't matter.
It doesn't matter. Good. Now, what about the next one? Are we done or do we have one more factor to go?
The 5.
The 5. Good, good, good. Now to get the final answer, guys, what do we do with the circle numbers?
Multiply.
Multiply them. So 2 times 2 times 2 times 3 times 5. Multiply all of these will give you 120. And we're done. All right. Any questions so far? Was everyone okay with the second practice problem? Yes, I'm gonna work out the second one. All right. So let's look at the two denominators for the second problem. We have y and 11. Now, can someone tell me can y be breaking down to any other factors here? Y.
No,
No, so we just circle that. What about 11? What factors are 11? Give me 11.
none.
None, right? Because it's a what? It's a prime number now. So since they're both primes, so for 11, that's just equal to 11. Y is equal to y. Circle each one. So then the LCD is we multiply each circle. So 11 times y, which is just 11y. Do not overthink these guys, please. Do not. All right, any questions so far? All right, we're off to the next section now. 4.8. Go ahead and give you about a few moments to set up the first one. So 4.8 is solving equations with fractions. Example, solve by multiplying the LCD. Solve 3/4 x equals -1/8. So what does the instructions mean, right? What are we having to do? So solve by multiplying the LCD. So multiplying fractions to the LCD gets rid of all your denominators, okay? So how, right? How does that work? Well, first for A, we have to find the LCD. So we have 4 and 8. So this is going to be a method one thing. So we want to find LCD first, right? So to find the LCD, we're going to do multiples of 4 and 8. So 8, 16, 4, 8, 12, 16. Notice that 8 is the lowest from the two. So my LCD for A is 8. Remember I said we're going to go back and forth, but we're mainly going to use a second one whenever it gets complicated. Here, 4 and 8, that's pretty simple for us to do. So now that we have the LCD, guys, you're going to learn about something cool that I think that it should be emphasized a lot, especially at a young age. So we're going to multiply the whole equation. So we're going to do 3/4x equals -1/8. We're going to put brackets around that equation. And we're going to multiply an 8 on the outside. So then we're going to show distribution by distributing the 8 to the left side and an arrow going to the right side. So now, anyone know how to make a whole number into a fraction? 8, how do we make 8 into a fraction, guys, without changing the value? To make a whole number into a fraction, you add a fraction bar, 8, and then put a 1 underneath, because 8/1 is the same thing as 8. So now I'm going to multiply 8/1 times what fraction first? 3/4. Don't forget the x is still there, equals. Then I'm going to do -1/8 times 8/1. Now we're multiplying fractions, guys. So when we multiply fractions, it's going to be the top with the top, bottom with the bottom, top with the top, bottom with the bottom. So we're gonna go ahead and simplify that. 8 times 3, use your calculator, is 24 over 1 times 4, which is 4. Now bring down the x, is still there, equals. On the right side, we're gonna do -1 times 8, which is -8 over the bottom, 8 times 1, which is 8. Now we're gonna go ahead and divide these numbers into our calculator. So do 24 divided by 4, and then we get 6x. Bring down the x, then we get -8 over 8, which is just -1. And check that out, guys. We have 6x equals -1. This equation right here that we just got to, 6x equals -1, is the same equation as.
Can you say that last part again? Sorry.
Oh, no, you're good. You're good. You're good. So we went ahead and divided out the numbers. 24 divided by 4 is 6. Brought down the x equals. Then we have -8 divided by 8, which gave us -1. Well, 6x equals -1, guys. This equation right here, this star equation, is the same equation as the original problem. We just changed the dynamics of it to make it friendly, user friendly. Because when you see 3/4x equals -1/8, that just makes our brain jumble a little bit. Yes, the procedure was a little intense, but 1, do we know how to do LCD? Yes. Well, 2, do we know how to distribute? Yes. 3, do we know how to multiply fractions? Yes. So these are all things that we've done before or have not done in the past. So there's nothing new here. But guess what? We're not done yet. We want to solve for x, right? So we have 6x equals -1. How do I get x by itself, guys? What do I do on both sides to move the 6 over?
Divide.
Divide. We're going to divide by 6. So now the 6's cancel. So then we're going to get x equals -1 over 6. And that's our solution, guys. We are done. What questions do we have on this first example here? Any questions on finding the LCD? Any questions on the distribution? Any questions on multiplying fractions or dividing? Okay, let's go ahead and take a look at B. First things first, finding the LCD. So we have x over 6 plus 1 equals 4 over 3. So my two denominators is 3 and 6. Count by 3s. And can I count by 6s? Can someone tell me what the LCD for B would be?
6.
Thank you. That is correct. Is everyone cool with how I got 6? If you have a question about why I got what or what I did for what, please ask, okay? So now we have the LCD. So now we're going to rewrite the equation, right? So we're going to have x over 6 plus 1 equal 4 over 3. I'm going to draw brackets around this equation. And I'm going to put a 6 on the outside. How many arrows, guys, am I going to be drawing to show distribution of the 6 of the LCD? That's 1. We have to multiply it to every aspect of this equation. But notice we're multiplying fractions. So how do we make a 6 into a fraction? Over 1. So then we're going to get 6 over 1 times x over 6 plus 6 over 1 times 1 equals 6 over 1 times 4/3. Notice now, Fatima Gul asked a good question. She asked, do we not multiply by top numbers? That is correct. When you do the 6, you do multiply to the top part of the fractions. That can also work, but that's just kind of like the overall part. Me adding the over 1 is breaking it down a step further, Fatima Gul. Essentially, we're doing what you're saying we're doing, but mine comes with the simplification process, which for the ones who have a hard time with fractions. All right, so I'm gonna go ahead and do this one. You know how there's a 1 without a fraction? I'm gonna just do that over 1, right? So let's multiply the tops with the tops, guys. So for the first fraction, 6 times x is 6x. On the bottom of that, what are we multiplying? 1 and 6, which gives me 6. For the second part here, we're doing 6 times 1, which is just 6 over 1. Well, 6 over 1 is just 6, so we don't need to put the 1 on the bottom if we don't need to anymore. Up here we did, so we know we're multiplying. And over here on the right side, we have 6 times 4, which is 24. And then 1 times 3 is 3. Now we simplify each fraction we still have. 6 divided by 6 is just 1x or just x. Bring down the plus 6 equals 24 divided by 3 is 8. That is the new equation we have now without fractions. And we got this new equation by multiplying the LCD. Now to get the solution, class, what do we do to get x by itself? We subtract 6. So then that cancels out. So x equals 2. And we're done. Any questions so far? All right. Here are some practice problems for you to try out. We'll go ahead and give you guys 3 minutes. Good luck. I'll add more time if you need it. All right, guys, does anyone need more time to work these equations out? Remember, first, you're doing the same thing we just did, finding the LCD. Two, multiplying it to the whole equation to get rid of the fractions to rewrite the equation. Three, solve the equation. All right, let's go ahead and type in your solution in the chat. All right, anyone have a solution for the first practice problem? Okay. So first, Nicholas, let's talk about what happened. So did you find the LCD for the first equation to get rid of the fraction? What did you get for the LCD?
15.
That's correct. So we got the LCD is 15. So we're gonna multiply the whole equation by that, right? Let me set it up. So we're going to multiply this 15 to cancel out these fractions, right? So how do we make 15 into a whole number?
15 over 1.
Good. So for the first arrow, we're gonna multiply 15 over 1 times 11 over 15 x equals -3 over 5 times 15 over 1, right? You here with me so far?
Yeah.
Okay, so let's multiply the two fractions on the left, right? 15 times 11, because we do the top with the top, what's 15 times 11?
165.
So then we get 165 on top over, on the bottom, what are we gonna multiply?
15 and 1.
Which is
15.
good. So I'm gonna bring down the x, right, equals. Now for the right side, what are we gonna multiply?
15 and -3.
And gives you what?
-45.
Correct. What goes on the bottom, sir?
5.
Good. So now we
Gotta be
use our,
there, I just didn't know how to divide it.
so now use your calculator, do 165 divided by 15. A fraction is just another way to write a division problem. So it's 165 divided by 15. Plug that into your calculator. Tell me what you get.
11.
11. What do we bring down?
The x.
Good. Now go ahead and divide the second fraction. Well, tell me what you get.
Nine.
What kind of 9 though? Because remember the 45 is a what?
Negative.
-9. Good. So now we solve for x, Nick. So what do we do, Nicholas? So how do we move the 11 over?
You divide
Correct. And when we do the one side, we do to the
the other side.
the 11s cancel and we get x equals.
-9/11.
That's correct.
I just got confused on the because I got down to the 165/15.
Ah, okay. So this part right here, right?
I just forgot.
So-
Yeah, that divide right there.
What? Yeah, you're good. So now we know. So pretty much when you get to that part, Nicholas, you want to use your calculator to divide those fractions for you, those numbers for you. So you should get a whole number after that. Now, if you were to divide 165 divided by 15 and it was a decimal, then at that point the LCD was wrong or you multiplied wrong. Okay.
Okay.
So let's try out the second one. All right. Let me have more time for the second one. Let's see if you can do it now. Okay. All right, guys, I'm gonna add more time for the second question. I'm gonna add 3 minutes. Good luck. Anyone want to share what they got for the LCD for the second one? That way, not the answer, but the LCD, so other students can check their work too.
So is the LCD always gonna be the first number?
No, that was just a coincidence.
Oh, okay.
Good question, though. Make sure, guys, that we're multiplying the LCD to all the parts of the equation on the right side. All right, that was my timer, guys. Does anyone have any questions? Or did y'all get the answer for the solution for the second one? Okay, I'm gonna go ahead and add some more time. Do y'all want an extra minute or two? One or two? We'll go ahead and give one since I have not heard yet. All right, let's see what y'all got for the solution, guys. The answer reveal is 10. Is that what everyone got, guys? What did y'all get? Feel free to share in the chat what you got. Doesn't matter if it's right or wrong. That way we can see whether or not I need to work it out or not.
That's what I got.
You got it too? Good, 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 good. Excellent, guys. Excellent, excellent. All right, would anyone need me to finish working this one out before I move on? Okay, so I'm gonna go ahead and start working it out. So I'm gonna distribute the 8 3 times right here, here, and here. So adding the 1, I'm gonna skip the step where I put the 8/1 next to each fraction because we know we're multiplying it, right? So 8 times y is 8y. On the bottom is 1 times 8, which is 8. So let me move this down. And then we have 8 times positive 3 is 24 over 1 times 4 over 4 equals, and then we have 8 times 2, which is 16. We have ones on the bottom, which is just a 1. So I don't need to write the 1 if I don't need to. So now we divide these. 8 divided by 8 is just y. Though 8's cancel out and give us 1. 24 divided by 4 is 6 equals 16. Subtract 6 on both sides, and then we get y equals 10. And we're done.
Can you move the screen up a little bit?
Yes, I can. And but when you forgot to turn the 8 into a fraction, did cause you to have any little mistakes, or were you able to get the answer, the correct steps without
Yeah, I
it?
went the equals. I went 16/2 because I multiplied the 1 to the 2.
Ah, because you didn't make 2 into a fraction, right?
I went 1 times 8, 1 times 4, 1 times 2, 8 times y, 8 times 3, 8 times 2. Wrote all my fractions out as 8y over 8 plus 24 over 4 equals 16 over 2. And
Ah,
then I brought it down as y plus 6 equals 8.
okay, there you go.
Because doing the division, 16 and 2
Gave you
is
the
8.
8. Yes.
So why
Well,
is that not?
because remember, just 2 was a whole number, right? Well, to make it into a whole number, Jacob, we have to put it over 1, right? And then we're gonna multiply 8 over 1. And remember the rule, top with the top. 8 times 2 is 16. But what bottoms are we multiplying, Jacob? 1 times 1, which is just,
Yeah, I didn't make it a whole number fraction. I just had a 2 there. So I got
And-
16.
and then you did the 1 with the 2 again because there was no other bottom number there. So, which is where your mistake came from, which just happens, dude. It really does. So the goal is to see your mistake now and hope it doesn't get repeated. All right, let's go ahead and move on, guys. Here is now new, there, we're adding a new steps. So we have step 2 through 6 already. So you're gonna write this here and then write step 1. Because this is a new step. And then the other steps you don't have to write because you did that in the other lesson. So other lesson. Now, if y'all want to take a screenshot or a picture of this after the step 1 and write the other steps in your notebook, you're welcome to do so. But we've done these steps before. No, only writing the first step because we wrote the other steps already. Now, if you want to write the other steps, you are welcome to. Not gonna discourage that, but I mainly want you to write the first step because you do have the other steps from the other lesson in chapter 3 when it comes to solving equations. Does anyone need more time to write this?
Yes.
Okay, let me know when you're good to go.
So these steps were from 3.3.
Yes, they were in chapter 3.
Okay.
Okay.
Okay, good, good, good. Anyone else need more time? This Sunday, Kayla. All right, anyone else need more time? Jacob said he's good. Anyone else before I move on? Last call. Okay, Josh was good. All right, if no one's saying anything, I'm gonna go ahead and move on, guys. Last example of this lecture. All right, let's look at example A. Z over 5 minus Z over 3 equals 6. Our job is to find the LCD for 3 and 5. 3, 6, 9, 12, 15, 5, 10, 15. We got 15. Now that we found the LCD, we're gonna multiply that to the whole equation. Z over 5 minus Z over 3 equals 6. So let's explain our steps now, right? Because we're gonna multiply it out. So first question first, how many arrows?
3.
Good. 1, 2, and 3. Next thing, before we multiply, every whole number we see, we need to turn into a fraction by how? Over what?
1.
Over 1. Is everyone with me, guys? All right. So I'm going to go ahead and multiply the first fraction. 15 times Z, the top with the top, 15 times Z is just 15Z. For the bottom is 1 times 5, which is 5. Everyone agree with the first fractions multiplied? Everyone good with that? Now I'm gonna do 15 times negative Z. 15 times negative Z is negative 15Z. Over 1 times 3, which is 3. Then write the equal sign, right? Bring it down, the equal sign. Then I'm gonna do 15 times 6, which I got 90. If someone can double check for me for 15 times 6, over 1 times 1, which is just 1. Now we're gonna take our calculator and divide each fraction to get rid of the fraction. Because remember, if we found the correct LCD, if we multiplied correctly, these fractions should simplify to beautiful numbers. 15 divided by 5, help me out. What was 15 divided by 5?
3.
3. And what should be after the 3?
Z.
Excellent. Then we're gonna divide negative 15 divided by 3. I believe negative 15 divided by 3 is negative 5. Bring down the Z. 90 divided by 1 is 90. Everyone with me so far? Now we need to combine like terms and solve for Z. So line down the equal sign. 3Z take away 5Z is negative 2Z. Bring down the 90. To get rid of to get Z alone, guys, we divide by what?
Negative 2.
Correct. And then 90 divided by negative 2 is equal to negative 45. And we are done. Any questions on any of the sets we just took, guys? Any questions at all? All right, let's look at B. We have x over 2 equals x over 3 plus 1 over 2. So we gotta find the LCD first. The two denominators is 2 and 3. Count by twos, 2, 4, 6. Sorry, I put 8. 2, 4, 6, 8, 3, 6, 9. We see that 6 is right here, so 6 is my LCD. We're gonna multiply that to the whole equation, so x over 2 equals x over 3 plus 1 over 2. All right. Draw your arrows to show what we're gonna be multiplying. Make 6 into a fraction. So we're gonna do 6 over 1 times x over 2 equals 6 over 1 times x over 3 plus 1/2 times 6 over 1. Now, it doesn't matter where you put the fraction first or last because we've established the order of multiplication does not matter. So now we multiply. 6 times x is 6x. 1 times 2 is over 2 equals 6 times x is 6x. 1 times 3 is over 3. Let me know if I ever make a mistake because I'm not perfect either, guys. And then the last thing, 1 times 6 is 6 over 2 times 1, which is 2. And now we divide these. 6 divided by 2, y'all, is 3x. 6 divided by 3 is 2, bring down the x. And then plus 6 over 2 is 3. Our goal is to get x alone, so we're going to draw the line. Subtract 2x on both sides. And then this cancels out the 2 x's, so x equals positive 3, and we are done. Any questions on LCD or distributing the LCD or simplifying? Any questions whatsoever?
Can you go up again so I can see the question, please?
Yes, I can.
Okay, thank you.
All right. Any questions so far? Did you get it, Sarah, or do you need me to scroll down some more?
Can you scroll down some more, please? Thank you.
Let me know when you're good. Hey, Beck, you going? Is this good? Let me know when you're good to go. All right, guys, we're gonna go ahead and move on. Jacob, you're good?
Oh, sorry. Yes, I'm good.
All right, last set of practice problems, guys. I'm gonna go ahead and give you about 5 minutes on this, and then we'll check on everyone how they're doing, okay? 5 minutes, good luck. Remember, finding the LCD, then multiplying it, and then solving for X.
Mr. Pacheco,
Yes.
on the second one, I'm able to just move that, like rewrite it, right, and move the y over 2 on the right side and leave the other stuff on the left side.
Oh, like flip it, you mean?
Yeah, that'll be fine, right? Or no?
Like, you mean like this, right? Like y over fifth plus 3/2 equals y over 2, like this?
Mhm.
Yeah, you could definitely do that. That is correct. Alright, guys, that was the timer. Does anyone have any questions on either the first one or the second one, or anyone still working? What did you get for the LCD for the first one? Y'all got LCD was 5. That's correct. Then you multiply that by 5. Make that into a fraction over 1, make x into a fraction 1. 5 times x is 5x. 1 times 5 is over 5. Then we do 5 times negative x, which is negative 5x over 1 equals 5 times 1 is 5 over 5. We divide this. 5 over 5 is just x minus 5x equals 1. Is everyone okay from this step to next one? Now, on the left side, we can combine x minus 5x, guys. What's 1 take away 5? One minus 5 is negative 4x equals 1. To get rid of the negative 4, we would divide. So we get x equals 1 over negative 4th, which is the same thing as negative 1/4. All right. What'd I get for the LCD for the second one? Correct, it's 10. Now, before we multiply, make the 10 into a fraction over 1, right? Now multiply the first fraction. Someone help me out. What's 10 over 1 times y over 2? What over what? 10 times y is 10y, 1 times 2 is 2. Then we do 10 times y is another 10y, 1 times 5 is 5. Then we do 10 times 3 is 30, over 1 times 2 is 2. Now let's simplify these together. 10 divided by 2 is 5y. 10 divided by 5 is 2, bring down the y. 30 divided by 2 is 15. Can someone explain to me the steps you get to solve for y? What do we do first? We have 5y equals 2y plus 15. Remember, guys, it's a practice problem, so it's on you. What do we do next?
Subtract 2y from the right-hand side and put, subtract 2y from the left-hand side.
Correct. So 5y take away 2y is 3y.
Right.
Bring down the 15. To get rid of the 3, we divide. So we get y is equal to 5. Let's check our answer. And that was correct. What questions, if any, do we have on the procedure here? All right. All right. I'm gonna go ahead and stop recording here.